Alright, hello everyone. This should be a short one today. So, we have a car driving around a track, right? And we're in centripetal forces. We're talking about circular motion. So, if I wanted to find the force friction, well, let's talk about the centripetal force. You guys should remember, centripetal force is mv squared over r. So the question becomes, what force is holding this car as it turns around? In other words, think of it like this. If this force wasn't here, then when you tried to make the turn, you would skid or you would slide. If it was real icy and this force was low, the centripetal force wouldn't be high enough to hold you in that circle. So those things should give you a hint as to what force it is we're looking for. And the force that is the centripetal force in this case is friction. Friction between the wheels and the road is keeping this car in place as it moves in a circular path. So all that means is when I have force centripetal here, you guys did this a bunch, it could be anything. It could be gravity, it could be tension. In this example, friction is the centripetal force. Friction is going to be pulling the car to the center of this circle. So this is F for force friction. So I can write force friction equals mv squared over r. Now if I was just looking for my force friction, I'm good to go. I have this equation. I have a mass of 1200, so force friction equals 1200 times my velocity squared. Velocity is 22, so this is 22 squared, divided by the radius. The radius is 100. Plug that in my calculator real fast. Let me know what you guys get while I'm doing it in mine. So if this was the weight or the mass of my car, its speed, and the radius of that turn, force friction would equal 5,808 newtons. You guys should all have been able to do that. So now the difference is, when we talk about force friction, right, just like force gravity can be mg, that's the equation for force gravity. If you remember from the beginning of the year, friction on a flat surface, the force friction is equal to mu mg, okay? Force friction is mu mg. So what if I didn't want to know the force friction? What if I wanted to know the coefficient of friction? That's this mu. Remember, this mu here is the coefficient of friction. It's how rough or smooth a surface is. It's how much friction it can have. So what if I was looking for that coefficient of friction? Well, the force centripetal is mv squared over r. The force friction is mv squared over r. Now from here, if I was looking for the coefficient of friction, just like when you see Fg, you plug in mg. If I see force friction, if I see Ff, I can plug in mu mg, because that is my equation for force friction. Set that equal to mv squared over r. And you should notice that the masses will cancel out. So if you're just looking for the coefficient of friction, you won't even need to know the mass of your car. All right, all the masses cancel out here. I want to get mu alone. I want to get the coefficient of friction alone. Divide both sides by g. So I get mu equals v squared over r times g. Plug in my numbers. Mu equals my velocity squared. That's 22 squared. Divided by the radius of 100 times g, 9.8. Plug that in. And I get a coefficient of friction, or mu, of 0.49-ish, 494. Okay, so that would be my coefficient of friction. Now, when you do these problems, and we'll talk more about it in class, if your speed right here, if this is too fast, and it's bigger than what force friction can be, like if I gave you the mu and you calculated force friction, if you find that you're going too fast, or you find that you're taking too sharp of a turn, force friction might not be big enough to equal that mv squared over r,